Hey Algebra 2, this is Mr. Osborne. We are going to go over Brave School for Unit 6, the rational functions. Couple details. First of all, you should have a worksheet. If you don't, stop and go to Mr. Osborne or Mr. Kershaw and get the worksheet. It's actually a review sheet, just like you did before the last test. And you got to complete that. So usually you did the work on a separate piece of paper, but now you actually have a worksheet where you're going to do the work. Second, watch the Edpuzzle video like we usually do. Go through the Edpuzzle video. It'll walk you through all the questions that are on that actual worksheet. So if you want to do your worksheet while you watch the video, you can do that. Or you can do the worksheet beforehand, try it, and then go back and watch the Edpuzzle video to see if you did it right. And then you can make your corrections there. The next thing is to check in with your teacher after you're done. Whether you're with Mr. Kershaw, check in with Mr. Kershaw. If you're with me, Mr. Osborne, check in with me. Check in for about 15 or 20 minutes to go over your work and see what you need to work on or what you need help with. And then, after we do that, schedule a time to take the test with me, Mr. Osborne. So whether you're in Mr. Kershaw or Mr. Osborne's class, you're going to schedule a time to take a test with me on Tuesday or on Thursday after school. But you got to let me know ahead of time. Or just come and check in real quick. You can come in on the Tuesday and Thursday and see if you can take it, but I may or may not be available. But if you talk to me ahead of time, you can be for sure whether you can do it or not. All right? So let's get started. So you all should have your worksheet in front of you, whether you've started it or not. Let's look at this first problem. The first thing we need to look for is this point of discontinuity. And now if you guys remember, point of discontinuity is also the same thing as an excluded value. It's a value that if I plugged it back into the actual function, it would make it undefined. So looking here, what number do I have to plug in there in order to make that function undefined? Well, it would be -1, because -1 plus 1 is 0, and we can't have 0 in the denominator. So our excluded value, or which is also the same thing as your point of discontinuity, the excluded value is -1. Okay, now the next thing let's look for is the horizontal asymptote, which we refer to as HA. And say maybe on the test you made a mistake and you mixed up the HA and the VA, or the vertical asymptote and the horizontal asymptote. Well, make sure you're paying attention to which one we're talking about. Okay, so in this problem, or in this function, let's look at the horizontal asymptote. Well, now for that number, we simply look on the number on the outside of the actual rational part of the function. Okay, and we see that we have this number -2 added to the function. So that is where we get our horizontal asymptote from. So horizontal asymptote is y equals -2. The next part is going to be our vertical asymptote, the one that runs up and down. And that would come from the denominator of our rational function. And if you remember, x is a what? X is a liar. So our vertical asymptote is x equals -1. A big mistake I saw is that a lot of people did not put y equals or did not put x equals. So you have to remember that asymptote has an equation. It's actually a line. It's not a line that exists. It's like almost like a limit. It's a place where there's no actual value. But in order to graph it, we need to consider it like it's an equation or a function. So that means we need to write y equals -2 and x equals -1. So let's go ahead and graph those. Let's start with our horizontal asymptote. It's at y equals -2. And we know that y equals is hoi, meaning horizontal line, 0 slope, right here at -2. And now the vertical asymptote, which is vux, or vux, which is vertical, the slope is undefined, and it's x equals at -1. Now the next thing you need to do in order to graph your function, well actually first, let's find the domain and the range. Okay. Now remember, domain is all the x values. Okay. And we note that by saying all real numbers except for some value. Because when we draw our actual line or function, the x can be any number except for one value. Okay, so in this case, it's going to be every value, all real numbers, and that's why I drew the R with the line, except for the value that is the same as our vertical asymptote, this -1. And then the same thing goes for the range. In this case, we're talking about the y values. And this is referring to our horizontal asymptote. Now, y can be any value or all real numbers, except it cannot equal, that's what that symbol means, cannot equal the same number as our horizontal asymptote, -2. And that's the nice thing about these graphs and these problems is that, for instance, the excluded value is -1. The vertical asymptote is the same value, but of course we write x equals -1. And then the domain includes that same -1 value, except we denote it like this. All real numbers except cannot equal -1. And then for the horizontal asymptote, it's y equals -2. And the nice thing is that the range is also the same, has the same value as the horizontal asymptote. All real numbers except or cannot equal -2. Now let's go ahead and graph it. The first thing we need to start with is an anchor point. So we need to start at the center of our graph. Start at the center of the vertical and the horizontal asymptote, and then pick an x value to the left, to the right and the left of that. So we have over here on the right we have 0. So we'll find the f of 0, and on the left we have -2. So we'll find -2. And the reason we're doing this is we need to find an actual point where this graph rests at. Okay, so I'm going to plug in 0 into our original function here to x. So if I plug in 0 for x, I get 0 plus 1. And then that 0 pretty much goes away, and I have 1 over 1 minus 2, which is the same thing as 1 minus 2, which is -1. So that first point, the x value is 0, and the y value is -1, and that's right here. And then for the next point, to the left of the center of our asymptotes, -2, if I plug in -2 here, I get 1 over -2 plus 1. And let's see, -2 plus 1 is going to be -1. So then 1 over -1 minus 2. And let's see, this 1 over -1 is the same thing as -1. -1 minus 2 is -3. So then our point there is at -2 and -3, which is, the nice thing is it's symmetrical. It's directly diagonal from the other point. Now we can draw and sketch our graph. So from this point, you draw a line that slightly curves and gets really close to your asymptote, but doesn't really touch and doesn't cross it. And then going from the other side, you draw another line that approaches the asymptote but doesn't actually touch. And then you do the same thing from the other anchor point. Gets really close but does not touch. Gets really close but does not touch. And there you have it. You have your hyperbola. Okay, now for the next one. Okay, we're going to go through this one a little bit faster. So now here we have an excluded value. Oops. Let's find our excluded value. Our excluded value comes from our denominator. And remember, x is a liar, so it is equal to +1, because x minus 1 is 0. Okay, now for our horizontal asymptote, comes from this number outside here, so it's just simply y equals 3. And our vertical asymptote, again, comes from the denominator. It's that same number as the excluded value, and x is a liar. And remember, with the asymptotes, we need to write it as an equation or a function. So x equals positive 1. And some of you are saying, well, wait, isn't there a negative here? Doesn't that change that number? No. The vertical asymptote and the horizontal asymptote is not affected by that negative in front of your function. That negative does something else to the actual lines, but it doesn't affect your asymptotes. The asymptotes are still come from the denominator here and still come from this number on the outside. Now for the domain. Now remember, domain is all real numbers except for the same value as your asymptote, your vertical asymptote. Because remember, the vertical asymptote has to do with the x values. And then the range, or y values, is all real numbers except for that same number as your horizontal asymptote. Y equals 3. So all real numbers except for positive 3. So now let's go ahead and graph this. So now we have our let's start with the vertical. We have a vertical asymptote, oops, sorry about that, at positive 1. And our horizontal asymptote at positive 3. Now, let's take a couple x values. Starting from the center, let's take one to the right, which is positive 2. And let's take one to the left, which is 0. Okay, I plug in 2. Let's see, then I have 2 minus 1 is just positive 1. And I have 1 over 1, but then there's also this negative here. So that will be negative 1 plus 3, which is equal to 2. And then for 0, plug in 0. 0 minus 1 is just negative 1. Then I have a 1 over negative 1, but there's also this negative out here, so that cancels these negatives out. So then I end up with positive 1 plus 3, which is 4. So now let's graph these points that we found. So now 2 and 2, so that's here. And actually, let's choose a new color. Okay, so 2 and 2, which is here. And then 0 and 4, which is diagonal from the other point. Now, draw your line, slightly curved, approaching, oh, that's a bad line. Draw a little less closer. There we go. Getting close but not quite touching. Getting close, not quite touching. Again, getting close but not quite touching. Getting close but not quite touching. Okay? Now, if you notice here, this graph, the lines have almost flipped. Before, on the graph to the left, you had a line here down in the bottom left and the top right. Now here, we have one in the top left and the bottom right. The reason that happened is because we had a negative in front of the function. Remember, a negative causes a reflection, or causes it to flip across the x-axis. And that's important to know for when you get to the transformation questions as well. So if anything, you always know that if looking on here over here on the left, that your anchor point is going to be from your center, it's going to go up 1, right 1. And from on the other side, it's going to go down 1, left 1. But then when you have a negative, it's just going to flip it, and it's going to be the opposite across the x-axis. Okay? All right, so now let's take a look at our next problem, our transformation. Okay, so now with this transformation, let's first look at our denominator here. And if you remember, x is a liar, so that would mean that if it's x minus 4, that's going to cause our parent function to move not in the negative direction, but in the positive direction, because x is a liar. So it'll go 4 right, and then looking at the number on the outside, if it's plus 3, that means it's going to go up 3. Okay? Now with this function, in this transformation, on number 4, take a look here at the bottom. We're going to have it's x plus 2. X is a liar, so it won't go in the positive direction. It will go in the negative direction. So that means it will go left 2. And then we have negative 4 out here, so that means it's going to go down 4. But there's one more transformation here, and that comes from this negative. If you remember, we just talked about it. That causes a reflection. A reflection across the x-axis. Okay? Okay, let's move on to number 5. Now we have to find the x and y-intercepts. This was a problem that I saw a lot of people struggle with, so pay attention here. Okay, let's start with the x-intercept. Now I know with my x-intercept that it's going to cross the x-axis. If it crosses the x-axis, the y value at that point where it crosses is 0. If we go back here and look at this graph up here, if you look right, let me show you a point, right here, there's our x-intercept. Now we don't know exactly what it is. It's some decimal or fractional type number here because it doesn't land exactly on a whole number. But I know, what I do know is that at that point where it crosses the x-axis, that y is equal to 0. So with knowing that, when I go back to finding the x-intercept, that means that if y is 0, that means I can set y equal to 0. Now if you remember, f of x is the same thing as y. So I will set it to 0 and then solve the rest for x. So first, I'm going to add 2, because I'm trying to, remember, we're always trying to isolate x. So that cancels out those 2's. And now I have 2 equals 1 over x minus 1. And now what I can do here is that since I have a fraction or a rational on one side of my equal sign, I can make this a fraction and then cross multiply. So now I'll multiply 2 times x minus 1. And then 1 times 1 is just 1. Let me draw my little arrow so that I can follow where we're going. And now I've got 2 times x minus 1, so I distribute that 2. 2x minus 2. And then do your last steps here. Isolate x again, so now we got to add 2 to both sides. Get rid of this 2 from the left. So now we have 2x equals 1 plus 2, which is 3. And then our last step here is to divide by the number next to x, which is 2. That cancels out this 2, and then we're left with x equals 3 over 2. Now, if you remember on the test, you were expected to draw that, you write that as a point, not just x equals 3 over 2, but we have to write it as a point. Now remember, y is equal to 0 at the x-intercept. So y is 0, and then you'll write your x-intercept value you found, 3 over 2. And there's your x-intercept. Okay? Now the second thing you had to find was the y-intercept. Well, the nice thing about the y-intercept is that I know when it crosses the y-axis, I know what the value of x is. It's always 0. Just like over here, the x-intercept, the y value is 0. Over here, the y-intercept, the x value is always 0. Looking back up at the graph, down here, here's our x-intercept, and it just happens to be an actual point, in this case, on this graph, and it crosses right there at -1, and the x right there is 0. So knowing that, with all these, y-intercept problems, I can just set x equal to 0 this time. So now, write the function y equals 1 over 0 minus 1, because I'm going to plug in 0 here for x, 0 minus 1 and minus 2, and now I'll just solve for y. So now 0 minus 1 is just negative 1. So now I have 1 over negative 1. And 1 over negative 1 is the same thing as just negative 1. So I have now negative 1 minus 2, which is equal to negative 3. So y equals negative 3. But remember also with the y-intercept, that's a point, so we're going to write it as a point. So now it's going to be x is 0 always for y-intercepts, and then the value you found, negative 3. Fractional form. So you can do negative 13 divided by 4, and you can also write this as the same 0 and negative 3.25. Okay, and you can do that for the x-intercepts in the other problem as well. And that might be a little bit easier for you to see visually, because then you might want to check, just look on your graph. Because remember, on the test, you're going to have a function. You're going to have to find the x and y intercepts of a function. You're also going to have to graph it, and you want to compare. Does my x and y intercept, do they even match up? Do they match up to my actual graph? Because then maybe I did something wrong. Maybe I didn't set x equal to 0. Maybe I set y to equal to 0 on accident when I was looking for the y-intercept. Okay? Okay, so now we're going to do some simplifying of rational expressions. Okay, so let's look at this one here. Now, what we have in the middle between the two rationals is a multiplication. If we have multiplication, that just means we're going to combine the top by multiplication and the bottom by multiplication. So let's just combine them in the first step. So now we have 8n to the 4th times 9n, and then 5n to the 5th times 7. And now the next step is we want to try to cancel out factors. Remember, we're simplifying. So what you want to do is break down these numbers or factor them out. Well, I know that 8 factors out to 2 times 2 times 2. And I've got 4 n's because it's n to the 4th. So now n times n times n times n times 9, which it factors out to 3 times 3. And then there's just one more n. And then do the same thing for the bottom. Now, the 5 is a prime number, so that's just itself. And then I have 5 n's, 1, 2, 3, 4, 5. And then 7 is also a prime number, so I can't factor that out anymore. And now we can cancel some factors out. So let's see. Well, the 2's, I can't cancel out any 2's because I have no 2's in my denominator. So let's move on to the n's. I see I have plenty of n's to cancel out, so I can cancel 1 here, 1 here, 1, 1, 1, 1, 1, 1. Remember, you can only cancel out 1 for 1. Okay, so if there's one n on the top, you can cancel out 1 n on the bottom for each one that you have. Okay, so I have 5 n's on the top, and I happen to have 5 n's on the bottom, so I can cancel out all of those. And then the 3's, there's no 3's on the bottom either, so I can't cancel those out. So now I have this 2 times 2 times 2, this 3 times 3, and then 5 times 7 on the bottom. And so all I can do for my last step is just multiply those together. Now I have, let's see, I have 8 here with these 2's, and then with the 3's I'll have 9. In the bottom I have 5 times 7, and then multiply those again, and I'll have 72 over 35. And I know that I can't simplify that any further because I already broke those down into their smallest prime factors, so there's nothing else I can do with that. Okay, next one. Now with this problem, got to be careful. What do we have here in the middle? Division. Okay, not the same thing as multiplication. Steps are similar, but the first step is different. Okay, you see division, that means you're going to flip the second expression or second rational expression. Okay, so before you do anything, you need to flip it. So now rewrite the first one. And now when you flip it, it becomes multiplication. So it goes from division to multiplication. And that's the reason we do it, because we can't really do anything with division. It makes things a little more complicated. So if you flip it, then you can actually do multiplication. So now I have 6 in the numerator now, and then 10n to the third in the denominator. Now the steps are the same as the last problem. Just combine the top, the numerator, and the denominator by multiplication. So we have 6n times 6 on the top, and 6n squared times n to the third. And don't multiply them together, because remember, we want to cancel out factors. So we want to break it down. So don't multiply yet. That'll be the last step. So now we have 6 over here. So that breaks down to 3 times 2. And then we have an n. And then we have another 6. So that's another 3 times 2. And then on the bottom, we have another 6, which is 3 times 2. And then n squared, which is 2 n's. And then 10, which breaks down to 5 times 2. And then n to the third, which is 3 n's. Okay, so now we can cancel out factors. I have a 3 up here, 3 down there, a 2 here, 2 down there, and here, and down there. No more 3's in the denominator, so I can't cancel that one. I do have a 2, so I can cancel out a 2, and then that's it. There's no more n's to cancel out, no more 5's. So now I just have a 3 here, an n and a 5 here, and then 3 more n's there. So now let's combine those by multiplication. So there's just a 3 by itself on top. And then on the bottom, I've got a 5, so I'll write that first. And then I've got 4 n's, so we have n to the fourth. So 3 over 5n to the fourth. Okay? Now let's take a look at this problem here. Again, we're simplifying. If you notice, it's not n equals or n equals some answer. We're not looking for a solution. We're just simplifying the expression. When we get to solving the equation, then I need an answer. But here, we're just simplifying the expression as much as we can to make it easier to work with. Okay, so remember, we've got multiplication in the middle. So we can go ahead and combine them first. Combine the numerator. Oops, sorry about that. We can combine the numerator and the denominator. So we have m squared minus 3m plus 2. All of that times this 2m to the right. And make sure you write that correctly, because it's this whole trinomial, m squared minus 3m plus 2 times, all of that times this 2m squared. Not plus or minus, or it's not just 2m squared times one of the numbers. It's 2m squared times the whole trinomial. And in the bottom, we have 2m squared times this binomial to the right, 3m squared minus 3m. Now, some of you guys are tempted to multiply, but you don't want to multiply. Okay, don't multiply yet. Now, what we want to do is break down these trinomials and binomials. And we're going to do that by first, this one to the top left, this trinomial, I'm going to factor it, reverse FOIL. Okay, so I know I'll have m here, and I know that 2 times 1 equals 2, and I know I can combine a 2 and a 1 to make negative 3, so that'll have to be minus and minus. And then to the right, this 2m, I can break that down to 2 times m. And then let's move on to the denominator, and then we have another 2m squared down here, so that breaks down to 2 times m times m. Sorry, let's put parentheses around that. And then this 3m squared minus 3m, well, I could factor that by taking out a GCF. And most of the time when you just have a binomial, or two terms subtracted or minus to each other, you're going to factor out a GCF. Okay, so let's take out a GCF here. So now I know I can take out 3m from both. And for the first term, I'm left with just m, and the second term, I'm just left with negative 1. Great, so once we factored it all out, now we can cancel out. It's my favorite part. All right, let's start with the top left here, this n minus 1. Well, I've got 1 on the top and the bottom. Boom, gone. N minus 2. Nope, I don't see any n minus 2 on the denominator, so can't cancel that one out. All right, next one, this 2, m and m. Well, I see a 2 here, 2 there, m there, another m here, and another m there. And boom, that's all we can cancel out. There's no n minus 2, and there's no 3 over other m to cancel out. So that's what we're left with. So rewrite your expression as m minus 2 over 3m. Come on down. All right, last problem for this page. Now, some of you guys might recognize this problem. Okay, so here again, we've got multiplication, separating our two expressions. So if you have multiplication, remember, we can just combine the top and the bottom by multiplication. So let's rewrite that by combining the top and the bottom, combining the numerators. So we have n plus 2 times n squared plus 3n minus 10. And then on the denominator, we have n minus 5 times n squared minus 4. Okay, so now what we can do is we can try to factor these out so we can cancel more factors. So the first one, the top, well, n plus 2, we can't do anything with that. There's no common factors between those two numbers. But I see I have a trinomial here, this n squared plus 3n minus 10. So let's try to reverse FOIL that. So we always have n to begin with. And let's see, if I do a 5 and a 2, and I need positive 3, so that means the bigger number's got to be positive, the smaller number's got to be negative. And negative 2 times 5 is negative 10, so that works. Okay, so now we have n minus 5. Can't really factor that out. And then we've got this n squared minus 4. Now I saw a lot of people make a mistake on this type of binomial here. Some of you guys thought, oh, well, that factors out to n times n minus 4. But if that's going to work, then it has to be true when I distribute the n back, right? So then that would be n squared times or minus 4n, which is not the same thing. So we're going to have to factor this a little different. Well, I know if I have n squared minus 4, that there's a 1 in front of that n. 1 is a perfect square. 4 is a perfect square. And it's separated by a minus, or subtraction. So I know that this will factor out to the square root of the second number, the 4, which is 2. And it will be plus 2 and minus 2. You got to remember that from our fracting back from Unit 3. If you need a refresher on that, come and see us, ask us about that. Okay, now I can do some canceling out. So now I've got an n plus 2 here on the top. I've got an n plus 2 here. I've got an n minus 2 here, n minus 2 there. And this n plus 5 cannot cancel out with n minus 5 because the first one's addition and the second one is subtraction. So I'm just going to write what I have left, n plus 5 on the top and n minus 5 on the bottom. And remember, this is just simplifying. We're not solving the equation. So we're just simplifying the expression. So that's all we have left. Okay? We're not looking for n equals or some solution. We're just simplifying the expression we have.